All right, let's do another example with the substitution rule. So in the last video, we tried to integrate a function using use substitution, and that required a little bit of manipulation. Once we got our u and our du, we needed to take our du and manipulate that a little bit more so that it more replicated our g prime of x dx. All right. So in this video, I'd like to take this a little bit further. We're going to try integrating a rational function that is going to require a u sub. And again, just before watching this, make sure you're all set with what the use substitution rule is, and also make sure that you know your basic integration tables. Those are important. All right, so let's try this example. So we will now try to integrate x squared plus 1 over x cubed plus 3x. All right, so I'm going to rewrite the substitution rule here. So we have integral of f of g of x times g prime of x dx is equal to the integral of f of u du. All right, so with that in mind, let's try to look for our inner function and its derivative. So inner function probably going to be one of the numerators or denominators. It's going to be one of those. But will it be the numerator or the denominator? So immediately what I see is I see an x cubed here and an x to the first power here. And then up here I see an x squared and I see an x to the 0th power here. So what does this mean? Well, it means if I differentiate the bottom, then with that derivative, the powers of that resulting derivative are going to be the same as the numerator. So if I tried differentiating, if I had x cubed plus 3x, and I differentiated that, then that goes to 3x squared plus 3. And I have an x squared term and I have an x to the 0 term, just like here, which means I can do some manipulation. All right, so now we have a good choice of u. We can choose u to be x cubed plus 3x. All right, so now we have u equals x cubed plus 3x. Now we're going to differentiate that and take du, and that's going to be 3x squared plus 3. Now we need to make du multiply it by a constant so that the right-hand side turns into x squared plus 1 dx. So to do that, if we notice we have three terms here, three constants there, then we have two constants of 1 there, or multiples of 1 there. So if we multiply du by 1/3, then we're going to get x squared plus 1. So now we know what the constant we should put at the beginning of our integral is. It's going to be 1/3. All right, so now with that in mind, we are ready to make our substitution back into our integrand, and hopefully if we do this right, this is going to result in all of the x's turning into u's, and it will result in an integral that we absolutely know how to compute. All right, so now that we know that, we can take the integral, or we can take 1/3 times the integral of du over u, and so we know du over u, that integral is equal to the integral of 1 over u du, and that means that this is going to produce a natural log. So you get 1/3, since we take the constant out, 1/3 times the natural log of the absolute value of u. All right, and now all that's left is to reverse substitute. We know u is equal to x cubed plus 3x, so we can plug that in, and that will leave us with our final answer of 1/3 times the natural logarithm of the absolute value of x cubed plus 3x, and of course adding our arbitrary constant of integration. All right, well, that was a third example for the use substitution. All right, so next video we are going to be continuing on with some more examples of taking these substitutions. They're very important, and hopefully you're getting the hang of it by now with this manipulation. If you're getting the hang of it now, maybe you don't need to watch the next few example videos, you can move right forward to thinking about how we do a definite integral with the u substitution, because there is a little bit of a hidden curve there. All right, so we'll see you next time for another indefinite example of the u substitution.